just pasting here to understand. So one more. So each switch link has its own dedicated cost to do a selection of root port. So like Ethernet 02 cost is 100 and Ethernet 03 cost is 100. Okay. So if I write here the cost is 100, the cost is 100, the cost is 100 and the cost is 100. So as per the definition of the Cisco, what Cisco is saying, recommending root to form a root port, we need a lowest path cost to the root bridge. If you see, if you see this path is 100, 100, 100. So let me read route down here like switch 2, switch 4, switch 3. Cost is 300, right? Because the cost of this link is 100, the cost of this link is 100, the cost of this link is 100. So once we combine everything, total cost of this link, first link, total cost of this link become 300. Now we have a second path, we have a second path, we have a second path from here to here like this. So cost of this path is also 100 and it is already here. So let me write down here, sorry, here switch to 3, sorry, switch to 3 and switch 1. The cost is 200 because this BPDO or frame, whatever you say, it travel from this link to this link. So that is the reason. That is the reason cost will become a 200. Now we have the very close path cost, which is directly connected to this root bridge switch, and the cost is 100. So there is another path which is switch to switch 1, and the cost is 100. So I said if this switch want to make a root port election, the switch must has a lowest path cost to the root bridge switch. And if you see, this link has the lowest cost as compared to link first, link 2 and link 3. This path is had at 300 and this path has a cost 200, and this is the path which is a have 100. It's the lowest path. So this is the reason it's become a root port. Oh, but if you see, every switch has a same code, same path cost, So this this single physical link is also path cost 100, and this is also path cost is 100. What is the second criteria? Please listen, this is very important. This is very important to form a root port. When the path cost become equal, when the path costs are equal, then from the root bridge, from the switch to when switch to listen BPDU from the lower interface. Listen, when switch to will receive a frame from lower interface. If you see in this design, switch 1 lower interface of this link E02 and the highest link is E03. So what root bridge will do? Root bridge switch will send a frame from lower port to this switch, and the lower port will become a root port. Root port. In this design, if you see, let me show you root port. If you see, as per the definition, E02 it become a root port, right? If you see in a design, if you see in a design, this E02 become a root port. Why? Because because switch 2 is or listening or hearing the message from root bridge of the lower port of E02. So second criteria only comes into the picture when path cost calculation is equal, when path cost has a similar cost, then this second form will come. Let me write in here. So to form a root port, lowest path goes to the root bridge. If path if path goes equal, then lower port of lower port of switch lower port of switch will become a root port. This fine, guys. Is there any question in this? Hello? Hello, Albert, Brando, Gurujit. Up to now, is this
No,
clear?
you said sounds good.
Up to now, is this clear?
Yes.
Okay, 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 okay. So, Cisco has designed some automatically, so like this issue, this is the Ethernet port, and this is the reason the path cost is 100. It's a because 10. Let me show you the some. I'm just mentioning the some default path cost of the switches redundant link. When it is I'm just mentioning for this. If you have a 4 MB link, then path cost value will is 250. If path cost value is 10 MB, then the cost will be 100. So this is a default predefined path cost of all the links given by the Cisco, and it is recommended also. If it is a 100 MB, then path cost sorry value will be 19. If it is a 1 Gbps of port like physical port, then the path cost will be 4. And if it is a 2 Gbps, sorry, 10 gigabit interface, then cost will be 2. So if you see, higher the bandwidth, lower the path cost. We can say higher the bandwidth, lower the path cost. Higher the bandwidth, higher the bandwidth, lower the cost. So this is a step second, election of root port. Now third step is election of a designated port. Election of the election of a designated port. Okay. So what is the criteria? What is the criteria so port can become a designated link? If you see in this design, each segment. So if I'm saying segment is nothing. It's just the physical link which is connected between the switches like switch 1, switch 2, switch 2, switch 4, and switch 4, switch 3, vice versa. So we have a many segment if you can see. So to form a designated port, the port on the segment that is connected to switch. Please listen carefully. The port on the segment that is connected to switch with lowest BID wins designated port. So I said if this port want to become if those this port want to become a designated port because this port is connected to this switch and it should closest or lowest to the BID. So this switch the if let me go to switch 2. I'm going switch 2. I'm going switch 2. C connector VLAN 1. I said if you see this port become designated port, like E00, E01. Why? E00, E01 become a designated. Why? Because this port is a secondary lowest BID. See, this is the first lowest BID ID. Let me write down here. Lowest first BID ID. Okay, this is the first lowest BID. This is the secondary lowest BID. Secondary lowest ID. This is very important because this topic I am covering as per the CCI. Even it is not part of the ENCORE. In ENCORE, it is just define the criteria. Theory it is written in theory it is written the election of the criteria. If this port is close to the root bridge, this will become a designated port. But I am explaining in the way of CCI topic. The same CCI guys, our experts are teaching to in this manner. I am sharing that knowledge to you. So from me, once you understand the concept of switching, wherever you go or you when you are doing yourself practice in the lab, you can do the same calculation. You have to understand in the same way. So that will be easy for you to understand spanning tree because this is also very important. Yeah, I think it's a 10 or 12 mark exam in the CCI and core of the land in when it comes to land topic. So this has become a second lowest. Let me take down third lowest BID, and this is the highest BID. Switch switch three is the switch four. Sorry, this is third. This is third, and this is the highest BID. Switch fourth is the highest BID because the last digit is 400 in EVNG iOS image. The MAC address burned by the iOS only in this one only to understand in an easy way. If you go into real world, the Cisco switches you have to do a show version. Once you do in the show version like this, show version, and there will be some command, there will be some MAC address display in the real iOS of the Cisco switches that you have to find out. So on that basis, every switch generate the MAC address on the basis of the MAC address which is present in this version. On that basis, it will generate the MAC address for the STP calculation. Okay, this is the fourth BID, which is the highest BID, but it's the fourth, which is the highest I can say. But logically, it's okay. So I said if this switch or okay, one more thing is very important. So as per the definition, to form a designated port, each switch port must close to the lowest BID. The port will become a designated port. So root port, if you see the switch one, all port are in. Oh, sorry, here it is there. If you see the spanning tree for VLAN 10, all ports are in designated role. Let me show you everything. Okay, all ports are in designated port. Why? Why these all ports are designated port? Because it is on the root bridge. Because this root bridge has the lowest BID. This is the reason all the ports are in the designated port. And once the designated port, this is status, which is a forwarding that I will talk later. No, right now we have to understand the election of the root bridge of a designated port. So if you see here in the switch 2, VLAN 1, if you see there are some port which became a designated, there are some port which are the root, there are some port which are alternative, and that is a block mode, and there are other port which are designated mode. If you go to switch 3, same way you have to do the same calculation, you have to understand. See, there are some port root, alternate, designated, alternate. So this port is okay. We are in the Swiss 3. Let's understand the Swiss 3. This port is become a designated E02. If you switch to E02, E01, sorry, E02. I'm on phase 3, E01, E01, E10, E03. Okay, see this ports E02, but I didn't see this is E02. It's E001. If we see E00, E01, this is also lowest. This is also close to the root bridge switch. So this will become root bridge ID. So see E001 root become and E10 is all switch on the alternative E/12. This interface is close to like this. This interface is close to from this to this interface, and that's the reason it become a designated port. So I hope you understand the designated port. Is there any doubt in the designated port? So please ask me, so I can clear right now. Do we have any question to forming about the designated port, guys? Please let me know. Hello Brando, hello Albert, hello Gurjit. This is fine.
Yeah, it's fine. I don't have any questions right now.
Okay, that's okay. Okay, once the designation, when the all switches done the designation, the next step is okay. Let me write down here. The lowest support is the lowest BID will become fingerprint shot. Oh, except the fourth step. Fourth step is a blocking port. Blocking port. Everything remaining. Sorry. Port will become blocking mode. So this is the fourth step of the root bridge, where default each port will become at the blocking mode. Why? Because it has a highest value. If you see in switch 2, if you see there is a port which is E03. E03. If you see this is the highest port of this, and that's why it's become it's a become a blocking mode. If you see on switch 4, we have a blocking mode. Let me go and switch 4. So spanning VLAN 1. Okay. So there are E001, E0001, E03, 11 and 12 become a blocking mode. So here switch has a highest BID I can say, and that is the reason switch 4 will have a most port in the blocking mode. So blocking mode means what? If switch port are in blocking mode, if doesn't mean that it is a state. Interface will up. If you see, I said this blocking port means it will not in the short mode. The interface will be up. We can see like this interface is less as 1. Interface is showing a blocking, but if you see this port is up, this port is up and connected, but it is in a blocking mode. That doesn't mean it will not receive any BPDO. Okay, let me show you. So spanning tree detail E E 1/1. Okay, that's one. It's BPU sent to receive to. So once it become so that is this this digit showing when it become the when the calculation was goes actually. If I do any changes, this port will become remain as it is. So next time it will never have another BPDO, because in blocking mode switch will never receive a BPDO because it is a blocking mode. Let me show you another, like E/13 E/13. Wait. You see, E/, is not here. Slash Okay, sorry. If you see E/13, the here the value was. Let me show you the value. E/13. The BPD was 11.55. Now, if you see the value again, it will change. See, E/11 E/13. See, it became 11.1188. 11.1188. Earlier, this value was 11.1155 because this port is, because here it is showing VLAN 0 is designated forwarding, path cost is 100, port priority 128, port identifier 128.1, designated port has a priority 3279. So this port is in designated port mode, and hence it is sending and receiving the, and it's sending only the BPDU to the root bridge switch. See, there is no receiving because this is a non-root bridge switch of the switch for the port is a non-root bridge switch. It just only send the BPDO to the root bridge one, and root bridge switch one is the root bridge. It will accept the BPDO. It will verify, and again it will extend to all the switches. This is how STP calculation. Now, one more thing, guys, you have observed. Can anyone tell me what is 128.1? Can anyone can tell me what is this value 128.1? Brando, Albert, Gurujit, can you tell me what is this priority dot neighbor? What is this? Can anyone tell me? Are you guys aware about this priority dot neighbor? Brando, Albert, Gurujit, anyone? Hello? Are
I
you guys
can't. I
there?
cannot tell you.
Yeah, tell me what is that? Go ahead.
Uh, I said I cannot tell you.
Oh, okay. So let me tell
I don't
you.
know what that
So
is.
let me okay. So I think it's, so if you see this priority 120 is same for all the interfaces, but this 128.1, and here you see the port priority value is 128 and port identifier is 128.8. This means I'm talking about this interface. If you did this, so 128, I believe everybody is aware the subnetting, the last 8 octet, this value is 128. 0 to 1, so like first octet, 1 2 4 16 32 64 128. I hope this octet value is aware everyone, right? So that is the last value is 128 is mentioned, and this dot 1 is the port number of this interface. This Ethernet 00 is considered as a 128.1. This is port number 1. So port priority dot neighbor is 128.1. Tell me, if this is not there, if this value is not there, then if this value is not there, which I told you, right, 120, sorry, 120, 128.1. If this value is not here, so I think Swiss 3. I was on Swiss 3. If this value is not here on this port, then how this switch will come to know to form a root port election? Because root port election criteria is the lowest BPDU receiving from the root bridge. lowest port number BPD receiving from the root bridge will become a root port. If this value is not in the VLAN database information, then the election will never happen. This is the reason this priority dot number value is given. This priority number is it's responsible to ensure the form of root port election. I hope, am I making sense to everyone? Hello, Brando. Is this you understand now? What is this priority dot neighbor? Is this clear? Brando, Gurujit, are you there? Gurujit, are you there?
Yeah, yeah.
Gurujit ji, your voice is very low. Can you speak loudly?
Okay, I'm saying please continue. Yeah.
Okay, thanks. So I think so. This is how this calculation is done. Priority dot neighbor. Now everything is done. Now fifth step, which will elect switch root root bridge elect election done, and now all switches all switches has a identical topology database. See, even in the way routing protocol like EISP, REAP, IGRP, OSP, EIGRP, OSP, BGP, they have some topology database. The same way switches also has a topology database. And when some changes, please listen, this is very important. When some changes is happening, that is called a topology change. Topology change. Okay, so these are all the criteria to form a root bridge election. But during this criteria, what is this status? If you see in the spanning tree, forwarding, blocking, and this rule, what are this? So when switch does the election, there are several state. There are several state. So we should know all the spanning tree state. That is very important to understand the spanning tree step. So if you ask me, this is the default we are running. So first is a blocking state. Now I'm talking about STP state. STP states.